That's 3. I need description cards, people. Oh, yeah. Here's another one. Okay, hang on now.
Just grab the fan and someone do
Can we go in?
Yes.
Okay. She said wait a second, so I need to go in.
One of the kids ran her out. Somebody's got a phone. Turn it off. Put it in your locker, better go. All right, y'all, your bell ringer. The top one is calculating the area of a compound figure. We did that yesterday. The bottom one is review from 6th grade. So we're finding the area of the gray part. Hopefully you remember how to do that. If not, we're going to go over it. Not a big deal. And while you all are working on that, can you please get out your homework from last night so I can come around and check it?
Found it.
Okay, yours is in the back. Good. Alrighty. Can someone tell me how to find the area of the little sideways heart thing? Just like yesterday? Shelby, come up and tell, oh, you wanna come up and show? Shelby, as soon as you figure that out, can you describe it to us and tell us what you did? About the 2's for 4. Okay. Do we have anyone that agrees or disagrees with that answer? Come on, you all talk more than this. She got 10 3/10 as the answer. Okay, anyone else? Okay, anybody else? Okay, Shelby, quickly, tell us how you got that answer real quick. Okay.
And the diameter of it was 2. And so I did the pi times 2, you get 6.28. So then I rounded it to 6.3. Then I took the square that was the option is do 2 times 2 to get 4. Then I added the 4 with the 6.3 got 10.3.
Okay. I like your logic. However, there's a little tiny flaw in it. And she used pi times d as her formula. Abby? Yes. Pi r squared. That's the formula that we use to find the area of a circle. You found the circumference. Pi d is the circumference. To find the area is pi r squared. So, instead of doing 2 times pi, what should you have done? There you go. Pi times 1 squared. And what is pi times 1 squared? You can do that in your head. Pi. So it would be 4. You got the square right. That's 2 times 2 is 4. And then you would add on pi. So 4 plus pi. Can you put that one up there for us? Plus, and then the area of the circle, if you put them together, would be just pi, 3.14. And together we get 7 14/100. It's negative. Very good, inches squared. Very good. So we got the top one now. How do we handle the bottom one? Lorelai? All right, you got 40 feet squared. Can you tell us what you did? Get there? Very good. She spoke awful quiet, so I'll say it a little bit louder. She did a great job. She found the area of the giant rectangle, and then she found the area of the little rectangle on the inside. And to get the gray part, you just subtract them. So the area of the big one was 80. The area of the little one was 40. If I subtract them, I get 40 feet squared for the gray part. Any questions? The bottom one is actually leading us into our lesson today. So we're going to be doing a lot like the second one today. Questions, comments? Okay, please put these back in your folder, make a stack. Noah and Tyrellis, will you please go around and get them from everybody? I'm going to share with you guys what we're doing today. Alright, I'm going to do a little bit of adjusting here. Lexi and Noah. Wait, who's this here? Noah? Okay. Lexi, will you please go sit next to Dylan? Noah, will you come over and sit here? And Emily, will you please go work with Katie and Leslie? All right. We're going to be doing something a little fun today, or at least I think it's fun. Hopefully you do too. And we are finding the area of shaded regions, just like what we did on that second question on our bell ringer, but this time it's with circles. We've been finding the area of circles now for, gosh, a week? We've been working with circles for a week now. So we're finding the area of shaded regions. So you're using what you learned last year and are applying it to circles now. But I'm not going to give you a whole lot of direction because I want you to use each other and a little bit of creativity to figure this out. Okay? I'm going to assign you a question. So I've got this paper cut up into little strips, and I'm going to give each of you a question to do. Make sense? If something doesn't make sense while I'm describing this, stop. Okay? We are going to get index cards, and they've got job descriptions on them. That means every single person in your group is going to have a job. Okay? You're going to be responsible for something. Okay? Very quickly, let me just tell you what they are. The first one is the mathematician. That is the person who's going to solve the problem, who's going to look at whatever assigned problem they get and solve the problem to the best of your abilities. Then I have a double checker, which means there's going to be a second person to solve the problem and see and compare what you all get. And if you both are having issues, I would suggest getting a third, well, then that would make it a triple checker then. And check to make sure you're doing okay. I have the artist who is going to recreate the problem out of construction paper. If you look in the back, you see the back? Okay, there's all the supplies that you are allowed to use to make your problem. Okay? The presenter. Tomorrow, we're not going to have time today, but tomorrow we are going to present our problems and tell the class how we did and how we got there. Okay, so there's one person that's responsible for presenting that information. And last but not least, we have the operations manager, which, and that person is going to get the supplies, is going to answer any questions you have, is going to check on everybody's progress, and if something is unclear, you're going to come talk to me. That operations manager is going to talk to me. Now I'm going to be up and around and helping you. I think you'll be okay. So I'm going to give you an example of what I did. I was my own group, obviously.
That's sad.
I know, it was sad. One is the loneliest one. I decided this one, and hint, hint, it was your bell ringer. So, just as a very quick review, I made this. So I took number 2, and I solved the problem, just like you all did. Found the big one, big rectangle, and subtracted the inside rectangle and got this pink that was left over. This is the shaded region. Make sense? Okay? Then, I don't know that you can see from far away, but on my rectangle, I solved my problem too. I found the area of the big rectangle, the area of the small rectangle, and then found the area of the shaded region. Okay? I put that all on my rectangle, found my answer, and I'm pretty much done. So now when I go to present this, which I kind of just did, you're going to do the exact same thing I did. Here's our work, here's how we solved the problem, and here's our final answer. Done. That's the extent of this little mini project. Does that sound horribly difficult? Nod your heads or shake your heads. Okay. Do I have any problems or any questions or anything before we get into it a little bit more? Okay. I'm going to come around and give you your assigned problem, and your job description. I'm going to leave it up to you all, Emily. I'm going to leave it up to you all to decide who gets what job. I trust you. So there's a little bit more of a description. Please use each other as a resource. I know you know how to do this, especially if you apply what we did this morning and from last year to this. You will be just fine. Okay. Here's yours. And here's your assigned problem. Okay. Here's yours.
No.
She just put that here and shake it. Okay. Here's yours. These are your job descriptions. And this is your problem measure. And find the area. Okay. I think you can get over this. But I think you all can handle it, especially. Here's your sign problem.